Welcome back to my channel Conquer the Fear. In this video, we are going to discuss about the top 10 ArrayList interview questions asked in the real interview. Now I can understand the pain if you are not able to answer a single interview questions on this particular array list, or if you miss to answer one of the interview questions which was asked inside the interview. Now the interview questions are like segregated into different sections. Now out of that, if one question is asked as an array list, and if you don't answer it, then it is not going to be looking good, because this is one of the basic collection of Java and you should be aware of all the. So covering this particular topic, I thought of making a video because this will be very helpful for you to crack that particular interview. In order for y'all to don't miss out any single questions asked by the interview, I have made this particular video so that you can actually prepare very well the array list concept. Now let's jump into the technical questions. So the very first question is, what is array list in Java? Now this is the very basic interview questions. Now this is definitely asked if you are starting with the interview questions and like he has just started with the collection section. Now exactly, array list is going to be an resizable array, and it is going to be the implementation of an list interface. Now according to the list, the collection hierarchy, list is one of the interface and array list is that implementation of an list. So if you go to that particular hierarchy, abstract class, abstract is there, list, and then the list interface is going to implement the array list over there. Now it will have different functionalities, like you will have some addition functionality, remove functionality. So if there is a resizing which is going to happen when the certain elements are inserted into it, so that's the underlying functionality of an array list. So it is dynamically grows and shrinks whenever it is required. Now as I mentioned, it is going to dynamically increase internally when that is trying to store the element, or it is going to dynamically shrink down as and when. Because if you compare it with the traditional array, this is going to be the dynamic, and if you compare the array, it is going to be the fixed size array. Now it is also going to maintain your insertion order. So you are trying to insert in certain order, that is going to be tracked up by this particular array list, and this particular array list is allowing you to store the duplicate elements and even the null values inside the array list. Now if you take a look at this, this is going to store the insertion order. Here you will see this will be stored as in this particular order, like 0, 1, 2, 3 and 4, and it is going to allow you, if you see here, there is a null which is going to be added over here, there is some apple, number 10. So in that case you can actually add those. Now let us try to look at an example in the code editor. Now let me open a program which I have already written for you all. Now if you see, this is an array list. If you see, look at this particular package, it is under the util package. So this is the implementation. If you highlight this, you will be able to see it is implementing the list interface, and it is going to instant the abstract list over here. So this is part of the collection hierarchy. Now if you try to see, this is going to store only the array list of type string over here. Now if you are not aware, this is the generics, where it is going to allow you to store with certain type only, and this one is the diamond operator, where it is going to be inferring this particular string from the left side only. So whatever it is mentioned on the left side of this particular diamond operator, it will be taken on the right side. So it will initialize that with that. Now if you see here, array list, as I already mentioned, it is going to maintain the insertion order. So you are trying to insert red, green and blue, and it is going to allow you to add null as well. So this is what we discussed. Now let's try to run this particular program and see whether it is going to maintain the insertion order or not. Now you see the way it is inserted, it is also shown in the system out println. Now this way it internally stores the element, and also it is going to display the elements. Now there are different functionalities as well, as I mentioned, where you can add the element, you can remove the element, you can do some operation on that part, you can get the element, right? So in that way you can play with the array list. Let us discuss the second question. What are the key important features of an array list? Now, this might be asked as an consecutive second question of array list. He might ask you the very first thing, like what is an array list, to understand whether you're aware of it. And once you answer that, he might ask you, like, what are the features or what are the benefit of it. Now, when it comes to the benefit, it is going to be, as we already discussed, it can dynamically grow. So, and also it can dynamically shrink automatically. You doesn't need to do anything about it. It is going to internally take care of the growing and the shrinking process based on the number of elements getting stored and removed from the array list. Second, it is going to be ordered collection. As we already shown you, like, it is going to maintain the insertion order the way it is inserted into the array list. So that is very important. In certain use cases, you wanted some things to be stored up in the insertion order. So in that case, it will be very useful. Then comes the allowing the duplicates. Now there are certain collections which doesn't allow you duplicates. Now this is an array list of implementation where it is going to allow you to store the duplicate elements. So you can actually add duplicate elements in this. Now the third or the fourth one is you are going to allow the null values. Now there are collections which doesn't allow null values to be stored up, but this is going to allow you to store the nulls. And then you this particular array list is used for a purpose, so it has got its own strength actually. So the strength of this particular array list is it is allowing you to randomly access, so it is quite fast when you're trying to access that. So it is as fast as O of 1. So the time complexity for this is O of 1 for the elements, which because it is going by the index over here. Second and the last thing is this, it is going to be the non-synchronized. Now it is not a thread safe by default. You have to explicitly make this as a thread safe by using the synchronization process. Now let us look at the third question, which is normally asked. Now explain the difference between the array list and the linked list. Now, if you are attending any interviews, this also has to be very important, because this is definitely been going to be asked up, because uh, interviewer focus not only the basics things, they're going to ask you the comparison between different collections available, when they are used, why are they used actually, what is their benefits and what are the features. So you need to be aware of all of this particular collection hierarchy along with their list implementations and the interfaces, and what set of functionalities it is going to provide you. Now when you compare array list, okay, or you define array list, so as we already discussed that it is dynamic array, it is going to dynamically increase it. So it is very useful for random access. Let's say you want to retrieve something with based on certain index, it is very useful. But because of its continuous memory allocation process, it is into the time complexity of 0 o of 1. Now insertion and deletion are going to be in the middle of something like O of n, because this every time then something is being inserted, then it has to shift those particular recreate that particular array and shift those elements which are there from the next of them. So there is a quite overhead in this, and then also there is an internal array being recreated and then adding those elements inside it. Now when you are using this particular array list, it is going to be very fast to access it whenever it is needed, but it is going to be very slow, or it is very less commonly used when it comes to the modification process. So the first thing should come into your mind is array list when you say the random access thing. Now, linked list, when you compare it with the array list, it is going to be the implementation as a double linked list. Now, this is very useful for the insertions and deletion. That is quite opposite to the array list, because here everything is maintained in an double linked list. So it is going to be either at the beginning and the middle or end of this. So it can update the references, but you can actually, when you're trying to retrieve something, when you're trying to get some elements, it is quite slow because it needs to traverse in O of n. So that is the reason it will traverse from the beginning till the end or from the end from the beginning. So this is going to be quite little bit time to retrieve process, but as it is going to be very fast when you're trying to update something or insert delete something inside. So use this linked list when you're trying, when you have a requirement of a frequent additions or a removal of an element from a list, and there is a less requirement of an frequently accessing those. Now let's look at the code editor with an example. Now if you take a look at this, I have imported this array list. I also imported the linked list over here. Now you see this is how you actually create an array list, and then you actually try to access and perform the operations over here. Now this is exactly what we discussed. It is used for random access, and this is used for faster insertion and updates. So you can actually, in this case actually it is quite important when you're trying to retrieve something. Let's say you're trying to get something based on the index, we can use it. Or actually if you're trying to insert something, let's say the linked list is quite helpful over here. That is the reason we use it over here. Let us take the example of the fourth question. Now, how does this array list is going to handle its capacity internally? Now, in order to answer this particular question, you need to be aware what exactly the load factor is, what is the initial capacity, then only you will be able to answer this. So, you have to understand the basics of array list, how the collection works when it comes to the load factor and the capacity. Now, when you, what happens when you try to outspace certain any of this particular array list? Now, when it comes to array list, the default size or the initial capacity what you say is usually going to be the number 10. Now when you add certain elements inside and then internally the array is full, let's say, okay, the array list is automatically going to resize by internally. Now typically let's say if you are trying to create an larger array, then it is going to increase in 1.5 times of the current size plus 1, or it can also double the size depending on the Java version you are trying to use or the implementation what you have done. Now this is going to copy all the existing elements to an exactly new array, and then it is going to add the new element inside it. So that's an overhead over here. So this is one thing when you are trying to insert element, delete something over here. So there is an extra operations of which is having internally. Now this is called resizing operation, and it is going to be the O of 1. So this is involving like trying to copy all each and of every elements inside the array list. Now let's try to take an example. Now if you take a look at this, I'm making use of the array list over here. Now you see I have defined the initial capacity over here. Now if you have noticed earlier, I have already created with the default constructor. If you see with the other like default constructor I was created, but here if you see I am passing the initial capacity over here. Now if you go to this particular array list, you will see there are different set of overloaded constructors. Now out of that, this is the initial capacity, now which is going to consider at the start of like whether this capacity is greater than or not, and check it, right? Now once you have this particular initial capacity created, now let's say after this particular 10th element, like we are trying to insert the tail elements over here. Now what happens, the moment the number 5 is done inserted, it is going to resize it because the capacity is 5. So it will going to trigger the resizing process the moment it finds the number element has fifth element has been inserted over here. So that's how this particular resizing works when based on the capacity has been configured along with the constructor. So if you see, when I try to run this, definitely this is going to insert that 10 elements over here, but it is going to be resized. Once it is not going to be the one initially what we have created, it has to do the resizing in between because we are increasing the number count inside this. Let's take the fifth example. Now, is the array list thread safe or not? This is a very important questions and very common interview questions. Also, this is the most confused questions. Now, how do you make this particular thread safe? If it is not thread safe, then how do you make that? Okay, so this is one of the counter questions, or the subsequent question comes in if you answer like if the thread safe is there or not, whether it is not thread safe, then how you can make the thread safe. We'll discuss that. Now, the answer to this particular is that it is not thread safe, it is not designed for that. That is the reason, the internal the structure is defined like that. We have different implementations for that as a concurrency API. We'll discuss that as well. But to answer this, it is going to be the no. Now, if there are multiple threads which are trying to access and modify an array list concurrently, that is, if there is no external synchronization being applied, then there can be a possibility of concurrent modification exception, which can be thrown, or it can also lead to an inconsistent data, because multiple threads are trying to insert something or modify something. So one thread can try to override something, some values, and later some other value try to insert something. So the third thread might inconsistently get the data. Now, to make this thread safe, we have to there are two ways to it. The first way is collections dot synchronize list. This is one of the method which is going to make your or wrap your array list into a list which is going to be in the synchronized list, where all of these particular methods are synchronized. So that's what's the synchronization be applied to all of those. Now, there is an concurrency package which has got introduced a similar kind of an array list, which is going to be the concurrent array list. So which is going to be the copy on write array list. Now, this is definitely going to be the thread safe, because this is one of the variant which has been introduced in the concurrent API. So Java util concurrent package. So how it works internally is that it is going to create a fresh copy of the underlying array for every modification what we do. So this is going to be quite efficient for the list that you are going to frequently read but rarely modified. So in that case, we use copy on write array list over here. Now let us try to take an example. Now if you take a look at this, I've created a thread safe array list over here. Now you see the first mechanism what we discussed. I've created a new array list which is going to be the synchronized list. Now if you see here, I'm trying to synchronize everything over here. Now, when you're trying to insert, it will be synchronized. If you're trying to add here, it is going to be synchronized, and it is going to ultimately print that. Now when you're trying to iterate using the synchronized list, you can actually use an external synchronization which is still recommended, because here this is going to give you a more granular way to handle this. Now you see this particular synchronized list, whatever it is here, uh, I have actually made it as a synchronized block, and then I'm trying to iterate it over there and trying to perform the operation. So this is how you make this particular array list as an synchronized. And also the alternative mechanism we already discussed, that is copy on write array list, which is a better way and a concurrent way of handling it in. Now let's discuss what is the fail fast behavior of an ArrayList iterator. Now, when you are dealing with ArrayList, definitely there is a process where you need to iterate, or where you need to go through those particular elements. So iterator is one way where you iterate each of this particular element inside the ArrayList. Now, ArrayList is an iterator which is called as an fail fast. Now, why it is called fail fast? Because when you're trying to modify the array list, the structural modification is happening. Then let's say you're trying to add something, when you're trying to delete something, then apart from the iterator own remove method, if you're trying to do this operation after the iterator is created, it is going to throw a concurrent modification exception. Now this is going to be a common interview questions, because many interviews ask you directly, like when do you get this concurrent modification exception. Now you can easily answer this if you know this particular concept. Now, as we already discussed, when you try to modify this, let's say you're trying to remove something, when you're trying to iterate, let's say list dot remove, and instead of using the iterator to remove it, in that case, it is internally identifies there is a mod count which has been maintained inside the array list, and it identifies that there is a what was the previous count or whatever the current count, it has been differentiated or it is not equal, then it is going to throw a concurrent modification exception. Now let's take an example of in the code editor. Now if you take a look at this, I've created an array list over here. I've added certain elements over here. Now here you notice I have added the iterator. Now if you take a look, I'm trying to iterate of this, and then I'm trying to add over here. Now I'm not doing anything, I've commented it over here. Let's say if I try to add something over here, you just see here what is going to happen. Now you see, the moment you try to add this, it is going to do the modification, the concurrent modification exception will be thrown up. Now instead of this, if you try to do, let's say, dot remove, and then you try to run this, now you see there is nothing being thrown up. Now that is the reason, as I mentioned, if you are trying to make use of the iterators remove method, there will be no concurrent modification exception thrown. But if you try to directly modify this thread, then it is going to throw the concurrent modification exception. Now let us discuss the seventh question. How do you remove the element from the array list? What are the implications of removing by index versus by object? Now when you're trying to remove elements from an array list, either using the index or either using the object itself, now it works in a different way, but we will discuss. So the with index, it is going to remove the specific position. Let's say you're trying to give, let's say, 1, 9, 10, or whatever element number over there, on that specific location it is going to remove it. Now all the subsequent element has to be shifted to the left. Now there is a time complexity involved over here. Now this can be O of 1 in the very worst case, because if you are removing the first element, then it is going, the all the element which is there, let's say 1 million records are there. Now all this 1 million records has to be shifted to the left. Now imagine how painful it is going to be recreating that particular array list, then trying to add those, copy those element over there. So it's a huge process and huge task over there. Now when you're doing the remove, you see object, it is going to be removed. Now in this case, it is not going to be like, it is the moment it finds the first occurrences of that particular specific element, it is going to remove that. If it is present, all the subsequent elements will be shifted from there. Okay, now again the time complexity can be same 0 O of n, as it might be it is iterating at the first element and then it is going to shift all the elements, right? So this might be the possibility, but yeah, it is, there is a little bit difference when you're trying to use this. If you take this example over here, I've created an array list. Now I'm trying to print this particular list over here. Now you see here, I'm trying to remove it with the index over here with that particular element. Now you see here the banana will be removed from here. Now it will print this, which is going to be based on the index. Now here actually I'm trying to remove based on the object name, whether it is, now currently it is string over here, but yeah, this can be removed. Now when I try to run this, actually, now you see the original of this is like this. Now after removing this particular, the first index, okay, now you see apple there, and then banana is removed from this particular list, as we removed the first element, second element, basically the 0 will start from the 0th one, and then it is going to the remove that particular element apple. Now it has removed the apple. Now only this cherry and the apple would be present after this. Now this is very confusing questions. Many interview try to fail over here because they are not aware whether this particular concept is applied to ArrayList or not. Because in Java you already know that we have the primitive types and we have the wrapper classes. Now Java, when you're trying to support the array list, when you're dealing with array list, it actually works on the wrapper classes, the counterpart of the primitive. It is not going to support. So array list is can only store the objects and not the primitive types, it is going to indirectly support the primitive types, which is going to be the primitive wrapper classes. So let's say int is there, there is a counterpart integer, character char is there, character boolean is there, there is a boolean, and double, for that there is a double, and then for rest of the other things. So to store this primitive value, you have to convert that to the corresponding wrapper classes. So there is, it is done. Now Java can automatically auto box it or unbox it, because it has got the automatic conversion features. This, because this was needed when you're trying to convert from, integer, I mean to say primitive to wrapper and wrapper to primitive. So this conversion was required. Now let's take an example and see. Now this is going to be one of the primitive inter array list. Now you see, this is one of the correct way to using the wrapper classes. Now here you see, I'm not trying to write an int over here. Now you see, if I try to write this, it says that argument type of primitive cannot be used over here. Now that's the reason integer, the counterpart has been used over here. Now you try to add an element. Now you see, I'm trying to add an integer only, right? But this is going to be automatically auto boxed to the integer, which is going to be converted to the integer wrapper class over here. Now let's say you're trying to retrieve that. Now this has been stored as an object over here. Now it is going to be unboxed and stored into the integer, the primitive type. So there automatic unboxing is happening over here. So this is seamlessly being handled by the Java internally using the auto boxing and unboxing. Now let's try to run this and see. Now you see here, this is going to run like this. Now, this is one of the important questions. He might suddenly ask you, do you know how to sort the array list? Now, we have already seen that particular previously, but we can sort it with the help of this collection sort method. Now, if the elements in the array list are some custom objects which you have created, so it is not going to be naturally sorted. It has to be implemented the comparable, they must have the comparable interface, that is the natural sorting order, or you can actually provide your own comparator that is used in the custom logic over there. Now we'll try to look at this particular example. If you take a look at this is one array list with some names inside it. Now if you see, when I'm trying to call this is going to be the natural sorting order that is comparable. So this is going to be applied over here. Now if you take a look at this, yeah, you see here, this is going to be the comparable over here. See, this is the natural sorting order over here, which is applied over here. Now if you see, it will print from, like, Alice, Bob and Charlie when you try to run this. Now let's say you have another array list over here and you want that particular things to be in a sorted order for this number. Now in this case, I'm trying to print this custom sorting order. Now here actually I'm making use of the comparator, which is internally going to make use of the compare method, which is used for the implementations when you're trying to compare between these two objects. Now you see, this is going to take the comparator over here. Now if you go to the comparator, you will see there is a compare method which is going to take input of both elements and try to compare, and based on the number it is going to decide whether it is greater, equal, or less than that. So this is how it is going to sort this. Now let's try to run this. Now you see here, this is going to be the natural sorting order. Now here if you see the custom logic which I have done, now the custom logic is like, I have written in the reverse order, right? So it is calling from the eighth, the biggest element, till the second biggest element and the least element. Now let's look at the last question. What is the initial capacity of the array list and how you can set it? Now what is this trim size? I know, like, you have heard this particular initial capacity now also and before also, but many of you must have not heard the trim to size method. We'll discuss that. But as we already discussed, the default size is of the array list going to be the 10, which is go when we are trying to create with a no argument constructor. So you can actually give your capacity over there manually, or if you're not, then it is going to be the 10. Now you can also explicitly set with the constructor, as we already discussed. Now when it comes to the trim size, Now in this particular method, it is going to reduce your ArrayList capacity to the current size of the list. Now in this case, what does it mean is that, let's say you have an array list created and the initial capacity is 10, but you have only stored it to 3 elements inside it. Now there are, 7 more spaces left out which is not being used up, and then also it's unnecessary over here, because let's say your requirement is only to store those 3 elements. Now in that case, you can use this trimToSize method to reduce that array list capacity to that, because we are only going to make use of that. And in this, you can save your memory. Okay, especially when you are using your array list which has to grow large, and then there are many elements being removed up. Now this is going to, leave you lot of unused internal array space, or like, it has happened like, there were millions of records and some have been removed, right? So in that case, there will be no point of keeping such huge size, right? So you have to make use of this to refactor that particular thing. Now let's take an example code. Now if you take a look at this, this is the which we discussed. Now here I've created an array list with the default capacity is going to be 10. Now let's say I wanted to create an array list with a capacity of 20 over here. So we can, in the constructor we already discussed, there are overloaded constructor over here. Now here I can add those element over here. Now the moment at the point where it is reaches 20, it is the but not like, let's say the uh, size is 20 over here, but you have only stored 3 items over here, as we already discussed, right? Now in this case, we have to call this particular method to reduce it to 3. So in this case, it is going to print the size. So before that, we will just print that the size and see what it that, and then it will print here. Now you see here. Now that's all with respect to the top 10 ArrayList interview questions. If this video was helpful, please give this video a thumbs up. Also, please share it with the needy people. Please do check out my channel, and also check out my other videos which I have made, which will be very useful for you, for your interview preparation, for your knowledge gain. Thank you. Thank you for watching.